So we've been asked to work out the area under the curve y is equal to x squared plus 3 for x between 1 and 4. So it's always good to draw a sketch. So we've been asked to work out the area A, so between 1 and 4 on the x-axis. Now for the Simpsons rule, we must split A into an even number of strips. So if you remember, for the trapezium rule, it doesn't matter. You could do as many strips as you want. You could do 3 strips or 11 or 12 or 14. But for Simpsons rule, you must do an even number. So for example, if we set the strip width equal to 1, then we get 1, 2, 3 strips. That's no good because 3 is obviously an odd number. So that will not work for Simpsons rule. So let's try setting the strip width to 0.5. And now we get 6 strips. Okay, so we've still gone from 1 to 4 on the x-axis, but now we have 6 strips. 6 is an even number, so that's good. Okay, and now we set up a table similar to the way you do it for the trapezium rule. You put your x values along here, so 1, 1.5, 2, 2.5. Okay, so all of those x values correspond to the x values along the edges of the strips that we drew. And then you use the original equation to work out all of your y values. And if you remember, we call these y values ordinates. So in this case, this is the first ordinate, the second ordinate, the third ordinate, all the way along. Okay? And then the Simpsons rule formula is you do a third times the strip width, then you have a bracket, and then you do the first plus the last ordinate, then you do 4 times the sum of the even ordinates, and then 2 times the sum of the remaining odd ordinates. And this is the only tricky bit really, but it's quite simple once you understand it. So whether an ordinate is even or odd has got nothing to do with these values. It only relates to the position in the list. So for example, this is the second ordinate, the fourth ordinate, and the sixth ordinate. So 2, 4, and 6 are even. These are the even ordinates. Okay? We know what the first and the last one is, that's easy. And then in the formula it says the sum of the remaining odd ordinates. So the only ones left in this case are the third and the fifth. So those are the ones we would put into this last bracket. Okay, so then we put all of those numbers into the formula, which you can see there. And then when we work through that, we get an answer of 30. Now, is this an overestimate or an underestimate? So you might want to use Desmos and a little bit of integration to check that out.